Okay, we are on PowerPoint 116 component identification, digital components. We're going to introduce logic gates and integrated circuits. Important stuff here, let's get started. Okay, so this presentation is going to introduce transistors, logic gates, integrated circuits, which are called ICs, and we're going to explain the relationship of each. We're going to describe the structure of a truth table and how to count in binary. In binary, that's your possible input combinations. We're going to present an overview of TTL, which is transistor logic, and CMOS, which is complementary metal oxide semiconductor. We're going to define the scale of integration and package styles. We're going to describe TTL logic gate numbering system. And finally, we're going to introduce manufacturer data sheets. Important thing right there. All right, transistor to gates. We talked about gates some PowerPoints ago. All right, let's see how it all ties together. So a transistor, it's an electronic device that is used to control the flow of electricity in electronic component with at least 3 electrodes. A small voltage controls a larger voltage. So a transistor can act as an amplifier. It can also act as a switch, meaning it can turn something completely on or completely off. All right, an amplifier can change the amount of electricity that something flows through. All right, we use it mostly as a switch. All right, so gates. Transistors and resistors can be arranged to create desired outputs based on specific inputs, which is called a logic gate. So I'm going to kind of summarize that. So transistors and resistors can be arranged to create an output based on the input. Because transistors have only 2 states, which are either on or off, binary number systems and Boolean algebra are used to describe the relationship of inputs to outputs on these gates. What does that mean? Well, binary means either 1 or 0, on or off. So it uses these binary numbers and some Boolean algebra, which is a way to work with these binary numbers, to create these desired outputs. These input to output relationships can be shown on what are called truth tables, and we'll look at a truth table here in a minute. So here is your basic AOI logic: AND, OR, and inverter. Okay, this is what we basically work with starting off. Okay, gates to integrated circuits, which are called ICs. An integrated circuit is an electronic circuit that has many components, such as transistors, diodes, resistors, and capacitors, all in a single package. All right, this right here, this diagram comes from a data sheet. All right, this is a 74 LS-SO8. What does that mean? Well, it's an IC chip that has a bunch of AND gates. Here is an AND gate. You can see this one has 1, 2, 3, 4 AND gates. All right. This is what the schematic diagram of that IC chip looks like. We don't really deal with this. We deal with this a whole bunch. So transistors go to gates, and gates go into integrated circuits. All right. This will be made a whole lot more simple in a little bit. All right. So here's common electronic components. You can see these are all IC chips here. Okay, integrated circuits. Here are the sockets that these integrated circuits go into. Okay. So there's a lot of different kinds. All right. You can see here, this is a 40-pin DIP, dual inline pin. All right. Here's a 44-pin PLCC. All right, which is a plastic leaded chip carrier. Maybe that's leaded. That makes probably more sense. All right, so all kinds of different packages here. All right, here's the good stuff. So gates and truth tables. So a truth table is a possible list of input values to a digital circuit. It's a list. It's listed in ascending binary order. So from least to greatest. Least significant bit to the most significant bit. You'll see what that means eventually. And then it also has the outputs. All right? The output response for the input combination. What does that mean? Well, when you have a 0 and 0 on your inputs, this specific output will happen. Right now we don't know what that is, but that's just what it's showing. So if we had a 0 and a 1, then this specific output would happen, and so on and so forth. So for two inputs like this, there can only be 4 outputs. Okay? The more inputs you have, the more outputs you'll have. That kind of makes sense. Alright, so how do you interpret a truth table? Really kind of easy. Alright, in order to understand the structure of a truth table, it is important to understand how to count in binary. Alright, binary is a base 2 number system. Alright, and I will show you that. It's really not too difficult once you start to understand it. Basically, it works like this. This combination of 0 and 0 equals 0. 0 and 1 equals 1. 1 and 0 equals 2. 1 and 1 equals 3. And so on and so forth. Alright? As I said, we will be able to learn to count in binary a little bit later on. Alright. So in this activity, it's only important to know that the truth table is showing all the possible output responses for each input. What does that mean? Well, since there are only 2 inputs, there's going to be 4 possible outputs. Alright. All the input values are listed in ascending binary order, least to greatest or most. Alright. Introduction to integrated circuits. Important stuff here. Alright, some of it. Some of it's a little bit more than we need to know. Alright, and that stuff I'll cover kind of fast. So ICs are categorized in 3 different ways. Alright. The underlying technology in which your circuitry is based on, meaning, what kind of gates it is. Alright, that kind of stuff. Scale of integration, small up to very large, and then the packaging style. Okay? So here's the 3. Okay, we kind of deal with this mostly. We don't really use these terms a whole lot. We'll see TTL a little bit. Alright, we'll see CMOS a little bit later on. We don't really use those kind of terms. Okay? But this is basically what we hit on most. Later on, we'll talk a little bit about medium scale and large scale, all that kind of stuff. And then the packaging style, as we get introduced to different kinds of IC chips, we will talk about some of the different packaging styles. Okay, TTL versus CMOS. Remember, TTL, transistor logic. CMOS, complementary metal oxides semiconductor. Alright, this is a little bit more than we need. Alright, so I'm going to just go through it quickly. Each has advantages and disadvantages. TTL, advantages, it's faster, and it's not sensitive to static discharge. Okay, you know how in the wintertime when you walk across a rug and then touch a doorknob, you get static? Alright, and it shocks you. Well, that shock would damage a CMOS chip. Okay. Disadvantages, it uses more power than CMOS. Alright. Complementary metal oxide semiconductors. Advantages, it uses less power, which is a big deal, especially when you start talking about large scale integration. And disadvantages, it's slower, which is a big deal, and it's very sensitive to that static discharge that I talked about. That's good enough. Alright, so here's the IC density of integration. So small scale, medium scale, large scale, and so on and so forth. Alright, small scale, logic gates, ANDs, ORs, NANDs, and NORs. Alright, that's what we really deal with. Okay. We will get into medium scale integration, flip-flops, counters, adders, multiplexers, demultiplexers. We talk a lot about this, both of these. This is early on, and this is about the end of the second quarter. All right, at least that's what it should be. The rest of this stuff, we'll talk about large scale integration stuff, PLDs, programmable logic devices, we'll get to. All right, but and we'll get into some microprocessors, but we basically stay in this range right here. All right, package styles, dual inline package. All right, that's what we deal a lot with. Both of these right here. Okay, this is surface mount stuff. We don't really get into that a whole lot. Mostly this. All right, and the reason why is this is great with breadboards, proto boards, and such, because you can just pop it in, pop it out. All right, this stuff over here requires soldering, all that. We're not going to really deal with that. All right, through the whole technology, THT. All right, so this is the ones that components have pins that you put into breadboards or into proto boards. Sometimes they can be soldered, and we will do a soldering activity later on. All right, and so on. That's good enough. Surface mount. This is stuff that is mounted on the surface of PCBs. No holes to be drilled. So there are disadvantages and advantages. Okay, we're going to very quickly go through this. All right, you can see here that this is highlighted. That's because that's what we deal with. That's what we're going to use. This is all the logic subfamilies. All right, all this stuff here, obsolete. Okay, it's basically, though, this is all the fundamental stuff, all right, that help create what we use. Now, what we use is borderline obsolete as well, but it's important to understand fundamentals of electronic components and gates and all that kind of stuff. All right, this is what we use. LS, when we say something is 74 LS04, LS stands for low power Schottky. Okay, I probably said that word incorrectly, but that's okay. We'll never say it again. Low power Schottky, 74 LS, 74. The LS means that. That's what we use. Okay, this other stuff we don't get into. All right. So TTL logic gate numbering system. All right, I'm going to go through this. We're not going to talk about it much though. All right. The manufacturer is the very first one. There's two major manufacturers of IC chips, Fairchild and Texas Instrument. Okay, we usually use Texas Instruments, so SN or N. All right, that's it. Okay, so 74 talks about the series TTL. LS talks about the logic subfamily, which is a low power Schottky. So 74 is a TTL series. LS is the low power Schottky. 08 is the logic function. So it could be an inverter, an AND gate, and so on and so forth. And then finally, N stands for package style, and we always use N. That means dual inline pin. Okay? Important here, manufacturer data sheets. So a data sheet has all the information that you're going to need. It's going to talk about basically the general description. Most important, one of the most important, it's going to give you the pin diagram. So when we start wiring up breadboards, it gives you the diagram that you need to follow. Okay? It talks about the function table, which is important, all right, or the truth table. So it's going to talk about what inputs it takes and then the desired output. Talks about the operating conditions and these other things here. But we really deal with that even more so up to the function table. Okay? Alright, so here is a data sheet for a 2-input AND gate, the 74LS08. This is a Fairchild. How do I know that? Because it's DM, and also it says it up there. Okay? So here is the connection diagram. That's what we use a lot. Okay? And here is the function table. That's what it's going to take these inputs and give a specific output. And that truth table or that function table tells you exactly what's going to happen. Alright, so this, they kind of already went through this. Here's a blown up version of the connection diagram. You can see that these are AND gates. Alright, input, input, output. You can see there's 1, 2, 3, 4 of these. Here's the function table. So we usually deal with zeros and ones with function tables. They're going to show it as L and H's, low and high. Means the same thing. L is 0 and highs are 1. Okay? And then you can see here the outputs are also in lows and highs. Alright, recommended operating condition. Alright, this basically what it's telling you is the minimum and the maximum input voltage input, because you know if you put too many volts through something it can burn out, all that kind of stuff. So this is basically saying this is what it's going to take. The minimum for it to function properly would be 4.75 voltage, and the maximum is 5.25. The nominal, meaning what it should be, is 5 volts. But this is the minimum of what it can handle, and that's the maximum. Alright, and then the units obviously is what it is. Okay? So it gives you some other information, talks about temperature and all that kind of good stuff. Alright? Okay, the electrical characteristics. Alright, we're not going to really deal a whole lot with this. Again, this is a little bit of kind of what I talked about. So if this was something that we absolutely needed, we can pull this up. But it's really not. Okay, most of what we deal with is 0 volts to 5 volts. Our breadboards are pretty consistent. So it's just basically discussing some minimum and maximum values. No worries. Okay, switching characteristics. This is way more than we need to know. Just talks about delay times, and we're talking about units in nanoseconds. That's way advanced, way more than we need. And finally, the physical dimensions. This is somewhat important. Okay, it's if we were designing circuit boards and things like that, it would be important to know the physical dimensions of your IC chips. All right. What it does do, it does give you a little, like some pin numbers, which are important, and it tells you with that circle or that half moon what where the first pin is. Okay. So that's if we were building breadboards, something that we're not going to do, or not breadboards, but circuit boards. Okay, we're not going to deal with circuit boards really. So this we do not need to know. And that concludes this PowerPoint.